Okay, in section 7.2, we're going to be working with proportions. Remember yesterday we said that a proportion is two ratios set equal to each other. You're making a comparison between two similar things. All right? In this proportion, A over B equals C over D, we have a property of proportions that says the product of the means is equal to the product of the extremes. Which means if you cross multiply, the products are the same. For instance, A times D is equal to B times C. For the purpose of simply being able to identify the means and the extremes, I have them labeled. The extremes would be your very first letter that you write down and your very last, as you're writing A over B equals C over D. And the means are the two center ones, the two in the middle that you write down. Okay? Now, when we set up proportions, we have to make sure that what we have on one side of the equal sign is directly associated with what's on the other side. So I have an example here where I'm going to talk about cats and dogs. And we're going to assume that we say, okay, we're going to add up all the pets that we have in this classroom. And we're going to pretend that the ratio of cats to dogs is 5 to 1. So what exactly does that mean?
Yeah, for every 5 cats, you have 1 dog.
For every 5 cats, you have 1 dog. Okay? Now, using this information, if I told you, okay, suppose you have 13 dogs. How many cats do you have? Well, in setting up a proportion, what we're doing is we're comparing basically a fraction of the same thing, just in different terms. So we have to set one ratio of cats to dogs equal to another ratio. In the simplified version, if for every 5 cats there is 1 dog, and there are 13 dogs, I'm looking for the number of cats, and here's my proportion. Cross multiplying, that means we would have 65 cats. Okay? Now I could also use this in a different way. What if I said the total number of animals
468
is equal to 96. And I want to know how many are dogs.
You would add 5 and 6, right?
5 and 6, 5 and...
I mean 5 and 1, that's what I meant.
Right. Because now what we're looking for is, we cannot say, all right, cats over dogs equals total over dogs. Because now you're not comparing the same thing. We don't know how many individual cats I have total, like out of our whole group. We don't know how many dogs, but I do know the total number put together. So I've got to make my two ratios represent the same information. So the total number over dogs is equal to the total number over dogs. Well, coming back to this original thing, out of 6 total animals, 1 is a dog. Out of 96 total animals, we want to know how many are dogs. And so now you have a proportion that's set up correctly. Cross multiplying 6 times D is equal to 1 times 96, and you divide both sides by 6. So you have 16 dogs. Could you go ahead and figure out how many cats you have now easily?
Yeah.
Subtract 16 from 96. There are 80 cats.
Or you can do 5
Where'd you
more
get this 6 from?
equal to 16 over x.
Or you do 16
We're looking for total animals over dogs. Well, if there's 5 cats and 1 dog, then that's a total of 6. Okay? So we have to make our proportions the same on both sides of the equal sign. All right. What if we have this as a proportion and we are asked to find the value of y?
Cross multiply.
We're going to cross multiply, but what I want to point out is, remembering from algebra, when I multiply 3 times that denominator,
You have to multiply each one.
I have to multiply each one by 3. Very good. I have to distribute the 3 to the entire thing, which will give me 3y plus 6, not 3y plus 2. And then now I can go about solving that equation. Subtract 2y from both sides. Subtract 6 from both sides. What's the value of y? Negative 6.
And would you need to find a proportion?
You may ask just to be can't talk. You may just be asked to find y, just whatever information is provided there. But I wanted to point out that when we cross multiply, we have to distribute there. Okay?
So,
Yes.
ratios aren't like fractions. You could-
Ratios are fractions.
Well, then you could turn two negative numbers, could you? To solve that.
Well, it would just be positive. Because if, let's put this, when I plug a negative 6 in here, I should get 3 halves.
Yeah, it's
Alright.
negative 6.
What does this reduce to?
Negative.
3 halves. Okay. It reduces to 3 halves. Okay. Looking at the classroom exercises on page 246, this is where this is coming from. Knowing that in a proportion, when you cross multiply means and extremes, that's where you get your two products that are alike. Which one of these 3 statements at the bottom is a correct answer, or would correctly, I don't know what I want to say.
The middle one.
Yeah.
Which one's correct?
Middle.
Number.
The middle one. Okay, the middle one. Why the middle one? Because if this is the proportion, then the product of the means is equal to the product of the extremes. So FG is equal to EH, and nothing else. Okay, nothing else. Now, what we're going to be doing here is we're going to be taking proportions and we're going to be writing them differently, but we still want them to represent the same thing. So I'm going to show you a trick. If the original proportion is here and we want to rewrite it, we need to identify what things are across from each other, because those products still need to be across from each other. So if 7 is across from C here, where does it go here? And 4 goes here. And this one we just flipped it. But we always want to make sure that we still get the same, we still get 7C and 4D. Okay? They have to be in the right positions across from each other. In this one, if my original proportion is E over F equals 5 over 9.
Yeah, F over 9.
Sorry, I didn't understand.
F over 9, because we still want to get 5F and 9E. Do we?
Yes.
Yes, we
I was
do.
just looking for patterns.
When we cross multiply, we still get 5F and 9E.
Yeah.
If G over H equals J over 8, then J over G equals what, Cressy?
8 over H.
8 over H. We want to see 8G and HJ. Do we?
Yeah.
Yes, we do. Making sure that our patterns remain the same.